Welcome, everyone. Today we are focusing on a pivotal moment in the machine learning lifecycle, taking a trained model and preparing it for the real world by registering it as an MLflow model. This is where experimentation meets enterprise engineering. Let's get started. To understand model registration, we must first look at the overall architecture of machine learning operations, or MLOps. In the inner loop, your data science team is busy exploring data, testing algorithms, and training models. In the outer loop, your operations team is focused on deploying those models to live endpoints. But how does a model cross from the inner loop to the outer loop? The vital step in between these two loops is to package and register the model. Think of model registration as publishing a finished book to a library. Once the data science team is happy with their model, they package it up and register it in the Azure Machine Learning workspace. This transforms the model from a temporary experimental file into an official, tracked enterprise asset ready for production. Take a look at this MLOps architecture diagram. On the left, we have the inner loop, which is all about data exploration and model training. On the far right, we have the outer loop, dealing with deployment and monitoring. The purple diamond in the center represents our topic today, package and register. This is the crucial gateway. You cannot safely deploy a model to an endpoint without first passing through this central registry checkpoint. Before we register the model, we must decide how to package it. There are several approaches you could take. In the past, teams often worked with basic pickle files to save their Python models. However, raw pickle files are dangerous in production because they contain zero context about the environment they need to run in. That's why we decide, alongside our data science teams, to work exclusively with MLflow. MLflow provides a standardized format for packaging models. When you log a model with MLflow in your notebook, it creates a complete directory. This directory includes not just the model weights, but a specific MLmodel configuration file, a conda environment file mapping out exact library dependencies, and an input-output schema signature. This guarantees that your model will behave identically in production as it did during training. Here we see the internal structure of an MLflow packaged model. It is not just one file. It's a comprehensive directory. At the top, the MLmodel descriptor acts as the brain, defining the model's signature. Beside it, the conda and requirements files perfectly map out the Python dependencies. At the bottom, we have the actual serialized model weights. This self-contained package ensures absolute portability across any computing environment. Why do we care so much about the MLflow format? Because it unlocks one of the most powerful features in Azure Machine Learning, no-code deployment. Historically, deploying a model meant a software engineer had to manually write a Python scoring script to receive web requests, parse JSON data, load the model, and return predictions. They also had to manually build custom Docker containers. It was a massive bottleneck. But when you register your model specifically as an MLflow model, you can opt for no-code deployment. Because the MLflow package already contains the input schema and dependencies, Azure ML can automatically generate the scoring script and build the runtime environment for you. You literally click Deploy, and within minutes, you have a live, highly scalable REST endpoint without writing a single line of infrastructure code. Look at the efficiency of this workflow. Our registered MLflow model enters the Azure ML no-code deployment engine. Because of the MLflow standards, the engine automatically splits out and generates both the scoring script and the Docker environment in the background. These combine instantly to spin up a live REST endpoint. It removes hours of manual software engineering from your MLOps pipeline. Registering models isn't just about technical deployment, it is fundamentally about enterprise governance. When you operate in regulated industries, you cannot have unknown models running in production. The model registry acts as your organization's ultimate source of truth. By registering models natively in Azure ML, the system automatically captures governance data for the end-to-end machine learning lifecycle. Every registered model has a rigorous audit trail. This logged lineage information includes exactly who published the model, what dataset it was trained on, why the changes were made, and exactly when it was deployed to production. Because it is an MLflow model, the registry provides a direct hyperlink back to the exact Jupyter notebook or training script run that generated it, guaranteeing absolute reproducibility. This graph illustrates the concept of lineage. A training run produces an MLflow artifact, which a data scientist formally registers into the central model registry. Because it's stored here, Azure ML permanently attaches lineage tags. We can always ask the registry, who published this, what data was used, and when was it deployed. This creates a completely secure and auditable chain of custody. How do we actually execute this registration? While you can definitely click a button in the Azure ML Studio UI to register a model, Enterprise MLOps requires automation. We execute registration programmatically using the Python SDK or the Azure CLI. If you are inside your training script or notebook, you simply use the command MLflow.register model. The brilliant part of this command is its syntax. You pass it a model name and an MLflow run ID. By using the run ID, you aren't just blindly uploading a folder of files. You are telling Azure ML to reach back into the tracking history, grab the artifact from that exact experiment run, and promote it to the registry. This guarantees that the registered model is permanently linked to all the accuracy metrics, loss curves, and hyperparameter logs generated during its creation. Let's walk through the code execution sequence. The training script runs, logging its parameters, metrics, and the model artifact to the MLflow tracking server. The tracking server replies with a unique run ID. The script then explicitly calls register model, passing that specific run ID and a formal model name. The model registry processes the request and responds with a success message, locking in the model as version 1. Machine learning models are not static software, they degrade. As real-world data shifts over time, a concept known as data drift, your model's accuracy will drop, and you will need to retrain it. This is where model versioning becomes critical. In Azure ML, you never delete or overwrite a registered model. Instead, you simply register your newly trained MLflow model under the exact same name as the old one. The registry detects the name match and automatically increments the version number, moving it from version 1 to version 2. This versioning system is a lifesaver for production environments. It means you can deploy version 2 to your live endpoint to test its performance, while version 1 remains perfectly intact in the registry. If version 2 behaves unexpectedly, you can execute an instant rollback to version 1 with zero downtime. This flowchart highlights the versioning logic. A new training run attempts to register a model named Diabetes Classify. The registry checks its database. Seeing that the name already exists, it triggers the increment version process. The registry now securely holds both iterations. Version 1 acts as our safe, active fallback, while version 2 becomes our brand new candidate ready for staging and deployment. To achieve true MLOps maturity, we must automate this entire process. We don't want engineers manually clicking register in a portal every week. Instead, we use GitHub Actions to automate our machine learning workflows. By storing our Azure Service Principal credentials securely in GitHub Secrets, we can write YAML workflows that command the Azure ML CLI. When a data scientist pushes new code, GitHub Actions automatically trains the model, packages it as an MLflow artifact, and registers it to the workspace. However, we must implement safeguards. Though automation is a critical aspect of MLOps, it is crucial to maintain a human in the loop. It's a best practice to verify the model before automatically deploying it. We achieve this by adding branch protection rules in GitHub, ensuring a lead scientist manually reviews the run metrics before the automation proceeds. Let's trace our automated CI/CD pipeline. The data scientist pushes code to GitHub. GitHub Actions takes over, securely triggering the automated training job in Azure ML. Azure completes the run and reports back. Here, the pipeline halts at our human-in-the-loop approval gate. Once the metrics are verified by a lead, the GitHub action uses the Azure CLI to officially register the MLflow model. Smooth, secure automation. Let's tie all these concepts together with a real-world scenario. Prosware is a young healthcare startup. They developed a web application to help medical practitioners diagnose patients more quickly. Their data science team trained a highly accurate diabetes classification model. The business challenge was scale. How do they reliably deploy this model to a real-time endpoint so the web app can get instant predictions? And how do they handle updates when the model suffers from data drift? The solution was MLflow and GitHub Actions. Prosware engineered a pipeline where the model is explicitly packaged and registered as an MLflow model. This registration unlocked no-code deployment, allowing them to spin up live endpoints instantly without custom scripts. Now, whenever data drift is detected, their GitHub Actions pipeline automatically retrains the model, increments the registry version safely, and updates the live endpoint with zero disruption to the doctors using the app. In our final diagram, we see Prosware's end-to-end architecture. Prosware's GitHub Actions orchestrate the workflow, triggering the Azure ML training job. The resulting model is securely packaged and hits our core step, register MLflow model. The new version lands in the central registry, which instantly pushes a no-code deployment to the real-time online endpoint. This robust endpoint seamlessly serves critical predictions back to the practitioner web app.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.